What's up, ladies and gentlemen? So I want to demo one of my new model rig combo things. This guy is called SLINK, and I'm going to go ahead and play while I explain him. But just on the left-hand side, we've got static camera. On the right-hand side, we've got camera that actually tracks the movement. But you can see that he's relatively simple, but just acts like a slinky, like a slinky. And he, I wanted to make something fairly simple, but that had the options to be like completely customized and changed. So, first of all, you can do a couple of things with it. You can change the length of it. If I make it smaller, you can see it's more along the lines of a box bouncing. And I'm also going to zoom in on the left-hand side of the screen so you guys can see a bigger picture of the control panel. And then on the right-hand side of the screen, you can actually see it moving and bouncing around. So, like I was saying, like a smaller box like object bouncing, and I can control the length. And you see we get a representation of essentially the slinky oscillating from the two jump points that it has. This is like a two-dimensional oscillation of the three-dimensional space oscillation here in the main camera viewport over here. So if I change the size, if I make it something very big, it'll look like it's actually walking, instead of slinking around or bouncing. And we've got a couple more options that we can do to it. We can control the speed. So if we want something super slow, like slow motion, it's gonna take forever to move across here. I'm gonna actually change it so that the length isn't so long, so we can get a better idea of it moving at a slower speed. There we go. So moving slower. Then I can change that to moving faster if I want. It's got a ton of options. Now, also keep in mind, this is just a completely simple representation of a possible model. Also, all these nodes represent joints and nodes that you can bind a mesh to. So, like, let's say if you have a character that's like an accordion character, I can put this object in like a really quickly. I can put it into a simple bind pose. And what I mean by that is if I show the control layers right here, I can grab these two things like this, pull them up. I think it's 17 is the right number. Yep. And I'm going to rotate this down. Let's see, -90, and also rotate this inward, +90. All right, and I'm going to increase the length all the way and pop into a side view. Now, if we look at the, like I said, the behind the scenes, like just the wireframe, the side view, this is, this is like a perfect rig position. Everything's spaced out evenly. It's going completely across. So if you just basically take these nodes that you parent, your joints to that, let's say you've already weight painted your skeleton and you just parent it to these nodes, then, see, it's going to move a little bit funky right now, but you can see basically how it works. It's how your skeleton could deform to it. And now the reason why it moves like this is because there's there's a good amount of math going into the all the calculations of it. Basically, what it's doing is it's saying at a baseline time or a time frame, while a node, and I'm going to turn on the back end of the GUI, so this is a little bit easier to see, but it's not all unfortunately, it's not going to be any easier to understand or explain, I should say. But you see, as this stuff is moving down here in the back end, what it's saying is if this area right here is 0 and over here is 10, when one of these joints, I think it's this joint, is 9 or greater, move this node right here, start moving it. And I think my baseline frame range was 4, and I figured that it needs to move a distance of 60. So every frame of time, unit of time, it moves 15 units of space. Now, let's say if we change the speed of that, then if we change the speed, we're going to run into the problem of the node being at the end, like greater than 9. It's not going to be greater than 9 for 4 units of time anymore. Because we increase the speed, we're going to have to like multiply by a ratio of that time to figure out how many units we should move this locator over the course of the period of frames where this node is 9 or greater or 1 or less. So that, I mean, that's the easiest way that I could explain the way that this math works. And because it works off things like that, you get really weird things. Like, for example, I've noticed that like if you hit play, you know, it's working fine. But then if you change something, like maybe the speed or something while it's there, you'll start to get really weird like distortions in it. Like you can see it's bouncing along, but it's, you know, it's becoming completely distorted. You're getting like really different results. But you know, aside from those weird results, you know, they're more interesting, I think, than the wrong. You know, it's another form of randomization that it could add to it. But along the lines of more like controlled customization that you can do to it, if I rewind all the way, I can grab these nodes, and I'm also going to turn on the back end control of the GUI so we can see like just a little bit more locators here. But see, I can actually move these points, these endpoints, to places that I want to create like a new trajectory for how this thing moves along. It's still going to move only like 60 units in Z, but when it moves like this, you know, it looks like it's a completely different movement. And also, and notice there's no flipping or unnecessary twisting with the normal of the curve. Essentially, by the way, this is just a motion path that's moving along. And I can turn off, right now, it's moving so that all of these points are aiming the way that they should. Notice how this midpoint is turning, how like rotating basically, so that basically all the endpoints are staying at the same up normal as this middle piece, so that there's no flipping or twisting. Now, let's say that I didn't want it to help me out with that. If I wanted it to just not, you know, orient correctly, then I could turn that off. And now, when I hit play again, notice we're not getting any flipping or twisting, but we're getting a really weird kind of like middle trajectory. I'm also going to turn off the controls so we can see what this is doing. You know, so this is one type of trajectory. It looks like it's spiraling through a sideways hoop, something like that. And then again, I'll turn on the the pathing, so that now it actually will. Oops, I think that I need to rewind it. Yeah, there we go. So I'll turn on the pathing, so it actually looks. It looks a little bit better when it goes through the middle piece. Let's see. Oops, hold on. Yeah. Oh, you know what? We'll have to fix that. But the middle one isn't actually rotating how it should. Oh well. But we'll fix that in a little bit. But anyway, just the other things that I wanted to show about this guy is that I said, all right, well, this is all, you know, well and good, but what if I wanted to take this, you know, further, even more customization? Like if I wanted to alter, like essentially the distance, like if I wanted to alter the position of the SLINK oscillating, but alter the position of space-time along the curve that's oscillating. And to do that, I created two things. I created just this one thing. It's called like, well, I'm calling it a cross-dimensional space-time remapper. Sounds way more complicated than it probably actually is. And again, this is all for virtual space, virtual space-time, and virtual time. And all those things are like, they all mean different things. But just to give you a better idea of this, I'll explain this in a different video. But I can take like my SLINK guy right here, and if I make him just a smaller smaller length right there, I can actually adjust the way that it's moving. So like let's pretend like if let's see, I'm going to turn on the second level of the time remappers. So you remember these guys, they're moving back and forth, the node start and end, basically they represent the end point and the two ends of the SLINK moving. So pretend like those are individual values and they're going back and forth between 0 and 1 or wherever units, whatever units that this snake is allowing them. So I force those values into the uval input. They each go into their uval input, their own time remapper, and we can see that it's moving at a ratio of space to time of 1 to 1 right now. However, I can adjust space to time. I can adjust the space time so that not only does like let's say like if this is the distance of the SLINK line, not only could like a position be a different point in space-time, but, or sorry, let's say a time could be a different point in space, but also a space could be a different point in space-time. It's like I'm not really sure how to explain it, but you can see just the customization that you can get by moving these nodes along, you know, and if I can make something very, you know, very different looking, and if I don't affect the start and end the same way, I'll get really weird results. So that's why they're all parented together. But see, if I change the way space-time occurs over these values from 0 to 10, you know, see, like I'm getting like a completely different, you know, thing. Like all of a sudden now along this curve, the middle section equals, you know, almost no time at all. So, you know, we can see right here how like space-time is completely changed, you know, and we can really see how stuff is moving along right here. Like that, still the same distance, still the same distance, still the same space-time difference, but it's still the same. Sorry, still the same distance, still the same time, but different space-time difference over dimension. And I'll just change it one more time to show the opposite effect that I can have. Oops. Uh-oh. Alright. Forgot that I had to control the master one. Alright, so I'm going to change it to the opposite effect. So now you can see that now there's a different point in space-time. And see, if you combine these with like the speed and the length, you can get really crazy looking things. Let's see. Let's do that. And I'm also going to remove the controls just so we can see this guy better. Maybe make him a little faster. These are the type of weird things I'm talking about. If you change it while it's already started, because it evaluates on every frame, it sometimes changes. But see, we're starting to get really strange things because we're remapping space and time over the course of the same time segment, same time link segment. But yeah, like I said, I want to make a crowd importer randomizer thing so that you can get a whole field of these guys jumping, wiggling around. I also want to make scooters that scoot along like that. Just a couple of other variations, and all of these things are going to, all these SLINK things are going to be in the same animation that Mr. Tubson's in. If you haven't seen the Tubson demo video, definitely check that out. He's a fat, cute Patrick SpongeBob-esque character. He has a lot of jiggliness, a lot of fun fat to play around and move, animate. Yeah, I'll post the crowd randomizer once I get that up. Thanks for watching.